Hello everyone, this is your tutor AB and today we're going to be looking at a May 2018 physics problem from the IB examinations. This is a paper 1 HL question worth 1 mark. A moon of mass m orbits a planet of mass 100 m. The radius of the planet is r and the distance between the centers of the planet and the moon is 22 r. What is the distance from the center of the planet at which the gravitational potential has a maximum value? Now, before we solve this question, there's a key concept that we need to understand to make this question a lot easier, and that's with the graph. So let me just draw an example graph. Let's say this is the graph for gravitational potential with gravitational potential on the y-axis. Let's say it looks something like this. We know at this point where I marked, we are at the maximum gravitational potential, but note the gradient or tangent to this point has a slope 0. And what does the slope represent? The slope of a gravitational potential graph always represents electric field strength. So if the slope of this is 0, the electric field strength at this maximum gravitational potential point is also 0. So using that, we can solve this problem. We can solve this problem using gravitational field strength. So let's solve this question. We know that both of these gravitational field strengths add up to 0. Okay, so let's say that for this planet of 100 m, so let's call this planet 1, it's a planet, so we just call it planet. We have the equation g, the gravitational constant, times the mass 100 m by the radius squared. So let's choose a random point between this 22r as, for example, this. And this, let's say this point is our gravitational field strength, GFS, equal to 0. Let's call this distance x, and let's just call this distance 22 minus x. Okay, so let's say this distance is a distance of x square away from the maximum value point, this planet of 100 m. That's equal to 0, but the other is also equal to 0. So we can directly say that the moon gm over 22 minus x whole square is also equal to 0. And as they are both equal to 0, we can equate them with each other, and hence we create this equation. Now let's cancel things out. gm will go, and let's continue. So we have 100 over x square is equal to 1 over 22 minus x whole square. Now what can we do here? We could create an equation using cross multiplication, but there's an easier way. What if we just take the root of both sides? That just means the root of 100 minus over x square, is equal to the root of 1 over 22 minus x, the whole square. Now what does this give us? 10 over x is equal to 1 over 22 minus x, isn't it? Now the math becomes a lot simpler. Now let's multiply on both sides. We get 10 times 22 minus x is equal to x. So 220 minus 10x is equal to x. 220 is equal to 11x. So x is equal to 20. And so 20 is the distance. 20r is the distance where the gravitational field strength is 0 and the gravitational potential is also at its maximum. So that's your answer.